se to do with geometry, okay? But they have a lot to do with learning, okay? Any of y'all look at the plaque on the outside of this building? Who this training facility is named after? Anybody seen that?
Yes, they know it.
Okay. Do you remember the saying under it?
No, I don't.
Okay. There is a thing that people do, I'm paraphrasing, that is a bar to all knowledge and enlightenment, and that is contempt prior to investigation. Okay? Curiosity, we've been talking about curiosity. Okay? If I have contempt for something, I will not learn. So I cannot have contempt toward anything I'm trying to learn. I have to embrace what I'm trying to learn. Okay? There's absolutely nothing that we're going to teach you in these classes that will violate any obligation you owe to yourself, your neighbor, your God, or anything else. We're going to teach you things that will help you be better in construction. And so there's no reason to have any contempt over what we're doing here, but as you go through your life, we've all had bosses that we had contempt for. Anybody ever had a boss that we had contempt for? I sure have. Okay, I've had owners, but Lord, I couldn't stand them. And I've had, guys going up that I couldn't stand. Okay, but how about that superintendent or that superior who helps you get your job done, is willing to give their knowledge to you? Now that's the leader I want to work for. Okay, so the purpose of this is to say, be careful of your contempt. And I think as you get a little further on in life, you'll find that you'll learn as much about the people you have contempt for as you do as you don't. But it's a whole lot easier to live and work with people that you don't have contempt for. But when it comes to knowledge, keep your mind open, okay? So I always call it how. How do I learn? Okay? And the first letter H stands for honest, open, and willing. If we will approach our lives with an honest, open, and willing attitude, with the desire to learn, okay, we will improve ourselves. We will improve ourselves. Just a little ditty on how. Doesn't have anything to do with mathematics, but it's a how. How do you get through life and get better? Honest, open, and willing. Okay, experiential story. 17 years old, on break. No, actually, I was 19 years old, on break during the summer, and I was asked to be a superintendent on finishing out a shop in McDonough, Georgia, okay, on 155 highway. Why in the world they put me as superintendent as a 19-year-old on a job is beyond me, okay, but they did. And I had 10, 15,000 square feet of shops. I was finishing out building partitions, hanging drywall, things of that nature. But this thing had something that I'd never seen before, a laundromat. It had a laundromat in it. And in this laundromat, of course, had under slab plumbing for all the washers and dryers and so forth. And it had a thing called a sand trap. Anybody know what a sand trap is? Yeah, it was a filter. It was basically, it's sort of like a grease trap. And so it was a device that was designed to catch the sand coming out of the wash and not get it into the sewer system, okay? Now, my uncle drew the plans and specifications, okay? My uncle had a very fiery man, bad attitude, mean, high-spirited architect. He's not an easy guy to get along with. So tell me what the detail looked like on those plans. It was a square on the floor plan, and it said sand trap. Okay? Did it have a section? Nope. Did it have a size? Nope. Did I know what to build? No. I was 19 years old. I didn't know what the hell I was doing. Okay? So here's a plumbing line coming in. Here's a plumbing line going out. I got a plumbing line, and I got a hole. I didn't know what to do. So after work, I went by my uncle's office and I said, "What's a sand trap?" He says, "You don't know what a sand trap is?" I said, "No, sir." And so he proceeded for the next 10 or 15 minutes to tell me how uneducated I was, how stupid I was, and I should this, and I should have that, da. Okay, so he dressed me down. He started my little left toe over on the right-hand side. He chewed up and over and went down out the other side. And at that point, I looked at him and I said, well, that's all probably true. But I still don't know how to build this damn sand trap. I don't know how to build a sand trap. And so he wouldn't answer. So I went to my dad's office. I said, look, give me a detail on how to do this thing. I'll dig a hole. I just need to know how wide, how deep, and what to do. And I got a detail. Now, what's the point of that? What's the point of that story? All of us have things in our lives that we don't understand how to do. Okay? It's not anybody's fault. It just is. And what are we looking for if we're trying to improve ourselves? Just looking for an answer. So it's not about personality. It's about being honest enough to say, I don't know. Open enough to say, I want somebody to help me with this. And then being willing to put up with some crap, but also being willing to accept the example. Every one of you on the job site has had questions. Okay? You've had questions about how to fit something up. Is this right? Is this wrong? Because we all want to do a good job. You didn't want to do a good job. You don't want to be a Benning construction company because we want to do a good job. So most of us want to know where the finish line is. Okay? How can I spend my labor, my work, my efforts, and do this work in a way that you're going to find acceptable? Because we're all doers. We express our significance in construction to others by what we do. Okay? We get fulfillment within our lives over seeing things happen. Okay? And so, as we go forward, I said we'd be a little bit off geometry, but back to how are you successful in life? Okay? Work on the how. Work on the how. Okay? All right. Dear Uncle Frank ended up being a minister, which was probably good for the world, because if he had stayed an architect, he might have caused a world war. I always said that it was good that he was tempered by religion, because he was a son of a bitch before it. Okay. Darcy, can I say those sort of things in our video?
Yes,
Okay.
it's encouraged.
Thank you. Okay, so we've talked a little bit about the properties of a rectangle. Okay? Any questions about rectangles and squares? All right. Let's see, that's more things on those good old, that's trapezoids. This is a fun one. Hollow rectangles. Now you'll notice the formula, we won't go through a lot of details on this, but it involves addition and subtraction as well as multiplication. We've got our D dimension and our B dimension, and then you have an interior dimension. See that? That is D1, B1. So, anybody here worked on any small shop spaces where you left the back, put a pour strip in the back, left the front out? Anybody worked on that? Okay. We'll draw a picture. Okay, you've got an area here. You have a building. This is the outside of the building. And you look at your plans and specifications, and they draw a line right through here, and they say 20-foot pour strip. Okay? And some of them will come here and they'll say, between partitions, 2-foot pour strip. Okay? Sometimes you'll have one where you've got a building and your pour strip runs around the perimeter of the building. Okay? Yes, sir?
Would that 20-foot pour strip be considered like a turn down?
Could be, okay? We're gonna stay in simple sections without a turn down for now. We can figure that up in a little bit, but let's just do area of that. We'll get to your question on turn downs. Okay, so we know from our previous that we know that this is what? D. We know this is B, right? That's a D right there, isn't it? That's a B right there. So we can calculate those areas fairly easy by using our formulas. Now in this example we have here, we have a D, and we have a B, and we have a D1 and a B1 and a B1. The little one right there is nothing but a variable. Okay, it's just another way to call a variable. We could call it P and Q. We could call it anything we want, but the mathematicians have decided this is a way to do it, and since we're not creating whatchamadoodles, we'll use their nomenclature, okay? Nomenclature meaning variables there. So, if this slab here is 50 feet by 50 feet, and this is 30 feet by 30 feet, who can tell me the area of that? So, let's use our formulas, okay? The overall area is D times B, isn't it? A equals D times B, which is 50 times 50 is what? 2,500. And let's call them square feet, okay? The interior dimension is what? Which is D1 times B1 is 30 by 30 is what? 900. So if I take 2,500 square feet and I subtract 900 square feet, 1,600 square feet. Okay? So you just basically play with your dimensions. So we're going to sidebar for a second on turn downs. Okay, let's sidebar on turn downs. Has everybody got that down? I'll erase this. Here it is. All right. Okay, turn downs. Once we get area and we take area and we multiply it by thickness, we get what? Volume. Volume, okay? A lot of times on a slab, you come up in front of a storefront or you go through a rear door and you have what's called a turn down, okay? So what I'm going to draw is a picture here of a turn down, okay? Now what I've done, we've cut the slab and we're looking at the side of the slab and we've got dirt back here. And more than likely, we're going to set kind of some sort of form here on the front for that, and that's a section line. And we'll pour that, and usually we'll have a couple of rebar down here in the bottom, right? And we'll have some wire mesh up here in the slab, and it'll come and turn down. Usually that's fairly standard detail, okay? So we know that we've got two parts of the calculation. Part number one is the slab. So if we use this as an example, okay, we use this as an example, and we say that we have got a turn down all four sides, okay? So the slab is thicker around the perimeter. We know that the area of the slab we're going to pour is what?
1,600 square feet.
Okay, and if it's a 4-inch slab, right, what is our thickness in feet of a 4-inch slab? 0.33. $1,600 times 0.33 is what?
528.
528 what? There you go. Cubic feet, because we took square feet times feet is feet to the third power. Feet third takes 3 dimensions to form a cube, right? So we know we've got 528 cubic feet, and that takes care of the slab here. So that volume has been calculated on our order, okay? Now, we then have got to calculate this. Now, for the sake of this conversation, let's say that the dimension, this is 1 foot 4 inches, this is 8 inches, and it comes back 4 inches. So that dimension is 1 foot 0 inches. Okay? So everybody clear on my pen scratching? So, from the bottom of the slab down to the bottom of the turn down is 1.4 inches. The width of the bottom of the turn down is 8 inches. It slopes back 4 inches so that it is 1 foot wide at the top where it intersects the slab. Okay? Now, the first thing I want to do is that I want to convert this into tenths and hundredths of a foot, because I'm going to be using a calculator on it, right? So 1 foot 4 is equal to what?
1.33.
1.33. 8 inches is equal to
0.67.
0.67. Oops. Okay, that's equal to 0.67. 4 inches is equal to what?
1.33.
1 foot is equal to what?
1.
Okay, so now I've got it all converted to the same unit of measure. Okay, I don't have foot and inches, I've got it all in foot now. Because you got to multiply, when you multiply a figure area or volume, you have to use the same unit of measure. Okay, same unit of measure. Once again, that's a system. Convert foot and inches into foots. Okay, right? So, we know that this is, what is the average width of this turn down? Well, how big is it at the bottom?
8 inches.
That's equal to 0.67 plus, what's the overall width? 0 divided by 2 equals what? 0.67 plus 1.67 divided by 2 is 0.83. Okay? Give me 8 inches plus 12 inches divided by 2 is what? No, 10 inches. Right. What's 10 inches over here? 0.83. What did we just come up with? 0.83. Okay? Yes, sir.
Divided by 2.
Because this is 8 inches, and that's 10 inches. Excuse me, that's 12 inches. I've got 2 dimensions.
Okay, gotcha.
Okay, so it's not a square, is it? Okay, it's not a square at all. Let's make it bigger. It's a form of trapezoid. Now, we'll hit trapezoids here in a second, but that's basically a turn down. Now, we all know that when you're in the field, you don't get that straight line, do you?
No.
No, it's more like this. Okay, but since we're dealing in theory, but it's the same thing. I mean, you gotta average stuff out. And, but the point, for the sake of our conversation today, we know that thing varies. Sometimes it's cut more straight, sometimes it's not. The goal is to make it look like a picture, sometimes it does. So we know, back in our example here, that's what? 8 inches, right? We know this right here is what? 12 inches. Now, if I was to lay this out on the table, okay, if you were to lay this out on the table, and we know that this is 1 foot at 4 inches, if I was to establish a center line down that turn down, okay, in other words, halfway between here and here, and measure this distance, we know that that is going to be 10 inches. Okay? So, in effect, what you're doing is that you're turning it into a square. Okay, you're turning it into a square because you're saying that this little triangle right here is really that little triangle right there. Okay, that's why you average the two. Does that make sense, what I just said? So in effect, what you're doing is that you're folding this over, and then you're folding it down, and you're turning that trapezoid into a rectangle. Does that make sense at all? And I will tell you that this area of this triangle will be exactly equal to that area of that triangle. Okay? And we can run it by properties of a triangle, properties of a rectangle, either way we want to go. We can prove it 10 ways to Sunday, okay? You know, another way you could do it, instead of taking 10 inches, is that you could turn this into a different, into entirely a triangle. There are lots of ways to do it, okay? You can run around in 50 different ways, but this is a pretty quick, easy way, a good system to do it. Just average your 2 dimensions. Average your 2 dimensions. Did I answer your question? Will? Yes, sir. Okay, good. If I don't answer your question, if you don't stop me, shame on you, okay? All right, so that's on you, that's not on me. I'll go as fast as you can go.
So that'd be the formula for it, to calculate that.
I'm sorry?
Would that be the formula?
Yeah.
Okay.
Yeah, that's the formula. Yeah, that's exactly the formula. So, now what we've done is that we now have the area of the turn down, right? But we don't have the volume yet, do we?
No.
Okay, so we know what is the perimeter of this square. We know that that is 50 plus 50 plus 50 plus 50, right? That's 200 what? Linear feet. 200 feet. Okay, so if we know that the area of this is equal to what? The area is equal to 0.83 times 1.33. What is the area of that turn down? 0.83 times 1.33.
1.10.
1.10. Okay, 1.10 times 200 is 220, right?
Yes, sir. 221.
221, okay, we'll go that. Okay, so we know that we have the additional volume of 221 cubic feet to add to our 528, right? That gives us 749 cubic feet. Okay, now how do you buy concrete?
Yard.
Cubic yard. How many cubic feet are in a cubic yard? 27. How many yards of concrete do we need to order? 749. 749 divided by 27 equals what?
27.7.
27.7.
We ordered 28.
Have you ever ordered 27? Hey, I'd like to order 27.7 cubic yards of concrete. What are you talking about? Okay, you can usually buy concrete within a half yard. Once again, how do you buy it? So you probably order 28 yards. Or you would order 25 and say you're going to do a callback. Right? Does that make sense? Mr. House?
Yes, sir.
You there? Good. So, that's how you get there, okay? Now, how many times will somebody say, you ain't got that right? You don't have that right. No, man, that's going to take 50 yards of concrete to do that. As you develop confidence in your numbers, okay, you don't have to worry about those kind of questions, okay? It's not an opinion about how much concrete is needed. It's calculatable. I don't know how y'all were as children, but I never particularly liked spelling because I didn't spell very well, okay, and I couldn't remember all the rules. And I really didn't like doing English papers because the teacher's opinion seemed to make more of an impression than what I thought it did. But man, nobody could argue with 2 times 2. Nobody was going to tell you you're wrong. 2 times 2 always equal 4. It was absolute, okay? That's the beauty of numbers. Okay. You might be off a digit, but it's not an opinion about what 4 times 4 is. Does that make sense? Okay. So we kind of digressed a little bit into the turn down, but we did go through the properties of if you have a block out in a floor. Okay. Now, if you're patching floors in the Publix, let's say you cut trenches for new plumbing lines, things of that nature, it's all length times width times depth. You're gonna take a linear footed trench, 2 foot wide, 2 foot 4, and you're gonna come up with a quantity, okay? So let's do another couple. Anybody need any more of this? I'm gonna erase this. We good? Okay. All right. Let's do one other thing while we're talking about slabs. And this will be, we'll put this on the public side. Public still have the detail where they put the dowels in the side of the trenches? Yeah. Okay. All right. So we have a trench here. And that trench shows a dowel being drilled into the side of that slab on either side. And what centers do they put these in at?
3 is a slab.
2 foot? Okay. So you'll see a note on the plans that says number 5 dowel at 2 foot 0 inches OC. Anybody ever seen that note? Something like that? Okay. What's the OC stand for? On center. Okay. So that linear dimension, let's just say for the sake of conversation, is 80. Okay? How do we convert that into pieces? Okay, because the dowel comes in a piece, right? How do we convert that? Well, we take the length of the trench, which that's good old D again, isn't it? Or is that a B? That's a B. That's B. Okay? So we take B and we divide it by the on center, 2. Okay? So that'll be 80 over 2. So how many dowels do we need?
40.
Actually, you need 41, but it divides to 40. Okay? Why? Because you have to add your point of beginning. You have to add your point of beginning. Okay? But with the 0 to 40, you got to have one at the 40, but you also have to have one at the 0. So when you have something on center, length divided by on center plus 1. Same thing on metal studs. Okay, if you're laying out a metal stud wall that's 12 foot long and you, just for the sake of easy math, you got 2 foot centers. How many studs does it take? 7. But you got to get your start stud, point of beginning. Make sense? I know you know that. Your daddy taught you that a long time ago. Yeah. Okay. Anything else on squares? Any questions? All right. Now we're going to go to the good old triangle. Anybody know who Pythagoras was? There you go. You got it. There you go. That's good. Okay. Pythagoras was an ancient who is credited with determining the properties of a triangle. Okay. In the Pythagorean theorem, which, believe it or not, is one of the building blocks of how you establish a square, okay, is attributed to him. So we take a triangle, and let's, for the sake of conversation, let's use a right-hand triangle. Okay? Let's see, that's next. Darcy? Oops, how do I go back?
Arrow to the left.
Arrow. Ooh, that's good.
Did you get it?
Yeah.
Okay.
All right. Now, for the sake of this, we got D, right? We got A, right? Is that right? Or is that a B?
B.
Thank you.
B, B, and C.
All right. How many of you have laid out a right angle using 6, 8, 12, 6, 8, 10? There you go. All right. So 6, 8, 10, 6, 8, 12.
6, 8, 12. No,
Okay.
yeah.
I think so too. Where's my calculator? Okay, so what Pythagoras figured out is that you can always figure the diagonal of a triangle, a right-hand triangle, if you know the length of the two legs. Okay, so his formula was C squared. Okay, what does squared mean? Squared is simply a number multiplied by itself. Okay, a squared number is a number multiplied by itself. What is the square of 3? Mr. McElhaney. 3 times 3 is 9. There you go. You got the square of 9. 9 times 9, 81. 10 times 10, 100. So we know that's a square. So we know C squared is equal to D squared plus B squared. So that was 6, 8, 12, is that right? 6 times 6 is what? 8 times 8 is what? 64. Oops, I made a mistake. That's 6, 8, 10, I thought it was. 36 and 64 is equal to what? What two numbers multiplied by themselves will give you 100? By itself. 10 times 10 is what?
C.
It's 100, 100, if I multiply 10 by 10, I get 100. So C squared is equal to 100, so the square root of 100 is equal to C. It's 10. Do y'all have any square roots on your calculators? Okay, just plug it in, hit your, put 100, hit your square root button. Tell me what number you get. Tyler got one. Yeah, Tyler may have to return one of his calculators. What do you got? Look at that thing. Keep hitting that thing.
It's all.
10.
Yep. Okay. So C squared. D. You lay out 6 feet. You lay out 8 feet, and you measure across. You're always going to get 10. Okay. That's how you determine a right angle. Okay, when you're laying out a building, surveyor comes out there and he gives you a point, right? Gives you a second point. He gives you a rectangle. You set your batter boards up and you pull strings. What's the first thing you do? Check square. Check square. It's a quick way to check square. You're laying out a room. You're laying out a comm room. Okay? A lot of folks will take their carpenter's square and they'll throw it on the floor to see if it's square, but what's another way to do it? 3, 4, 5, 6, 8, 10. Okay, just real quick. It just helps you as a superintendent be sure you're right. You don't want to have a skewed wall. You have a skewed wall, so you see on top. Okay. All right. So we figured out now how to figure the distance of the 3 legs of a triangle, right? So how do we figure the area of a triangle? All right, let's go to our page showing triangles. And let's look at our formulas. Okay, bottom of the page. Okay, that's axis, isn't it? I want to go back one. I'm going to go up one more, sorry. Go back. Okay. Area of a triangle, right, is equal to what? Over
2.
2. Okay, so if we take a triangle here, let's just take a triangle. Okay, and we're going to make this 6. We're going to make this 8. Okay, so D is equal to 6 inches. B is equal to 8 inches. What's the area of the triangle? 6 inches times
8 inches.
8 inches. We multiply that over 2 is equal to, 6 times 8 is equal to 48. 48 divided by 2 is equal to 24 square inches. Okay? Now let's do that using decimals instead of using inches. Okay? 6 inches is equal to what? 0.5. What's 8 inches?
0.67.
0.67 over 2. Multiply those two.
0.16.
Say again?
0.16.
0.16 what?
75.
Pardon?
0.1675 is the total.
No, that ain't what I meant. I meant a unit of measure. That was cute. I like that.
Yeah.
Yeah.
That's it. So
Huh?
you have 2 inches.
It's not inches.
Square inches.
No, it's square feet.
Square feet.
See, we converted inches into feet.
Yes.
Feet. You see that? Okay, I see a little bit of mystery, so let's get going through that. Okay? The first time we went through it, we did it in inches, right? We said 6 inches times 8 inches over 2, okay, is 48 square inches divided by 2 is 24 square inches, right? Now, we then turned around and we said, okay, let's do that feet instead of inches. And we said, okay, so 6 inches is half a foot, 0.5. 8 inches is 0.67 feet, or 3/4, okay? Right? 3/4. Over 2 equals 0.16, okay? How many square inches in a square foot? 12 times 12 is 144, okay? Somebody multiply me, take 24 and divide it by 144, tell me what you got.
166.
Ah, there it is. Is the light on? Okay, we took square inches and divided into square feet. Okay. This is where most folks in construction have trouble. Okay, most folks. Now, once we do that, we now throw fractions in. Okay, which fractions are a whole different horse that you got to deal with. But fractions can be turned into tenths and hundredths of a foot, just like inches can be. Okay? So, let's play a little bit with fractions now. Are we good with that? We good on triangles? Okay, all right. Let's have some fun with fractions. Y'all don't look like you're having much fun with fractions right now. Why are we going through fractions?
If you convert them, maybe easier to add.
That's it, but where do you see fractions? Oh, they're all over the darn place, aren't they? How thick is drywall?
5/8.
Or half, right? Sometimes thicker, okay? How wide is a 4-inch metal stud? 3.5 inches, right? Why do they call it 4 inches? I don't know. Sometimes you can buy a 4-inch metal stud, it's really full. Right? Okay. Yeah, drywall metal studs, you can actually buy true 4s, but that's okay, that's a sidebar entirely. Okay, so we did inches into tenths of feet. Okay, so 1 1/2 inches is equal to 1.5 inches. Okay, everybody see that? 1 1/4 inches is equal to 1.25. 1 3/4 inches is equal to 1.75 inches. Okay, so what we're doing right now is we're taking fractions and we're turning them into decimals. Decimals, not decibels. If we were listening to music, we'd be doing decimals.
Yeah.
But decimals. So, we know that if we have a dimension that is 20 foot, 4.5 inches, right? The first thing that we do is that we convert it into decimals for inches first. So that would be equal to 20 foot, 4.5. Okay? Now we know that 4 inches is 0.33. And we know that 5 inches is 0.42. Right? Somebody add 0.33 and 0.42 together. Divide it by 2. Divide it by 2. 0.3 what? 375. So we know that that's equal to 20.375 feet. Okay, so what we just did is we took foot in inches with a fraction. We converted it to foot and inches, turning the inches into decimals. And then we turned it into feet. Now, if I told you, I said, okay, I want you to add up, we got a string of dimensions, I've got on the plans 20 foot, 4.5 inches, plus 10 foot, 8.5 inches. Right? To add those two together, how would I do that? I would take a 1/2 inch, plus a 1/2 inch is what? 1 inch. 4 inches plus 8 inches is what? 12. 20 and 10 is what? 30. That's 30 foot, 13 inches, right? Of course, you never see 30 foot, 13 inches on a set of plans, do you? You would see 30 foot, 31 foot, 1 inch. Okay? So once again, the system, okay, you can add the fractions that way. Now let's turn it into decimals, okay, using this formula. We know that that is 20.45 inches, isn't it? And we know that is 10.71, I think is going to be pretty close. Yeah. Okay, inches, 10.71 inches. Okay. Okay, 20.45 inches. Okay. Is what in feet? I got my point wrong here, sorry guys. together.
So 31.085.
31.085 is what?
31,
31 feet 1 inch. Okay, what time is it, Darcy?
9:50.
Let's take 5 minutes. We'll come back to this. Everybody take a break.